Assalamu alaikum, dear students of first year class. Now we are going to continue our preparations. In my last lectures, I have delivered lecture on a short questions for the exams point of view, and it's according to the chapter wise. I have almost done 6 chapters, and all the short questions I have sorted out from different chapters. I again explain, just try to focus on the questions which I have written on these slides, and try to sort out the answers from your relevant books which you are going to read, which you are going to consult. It may be A plus, it may be any other book, right? So these questions are important. Answers are not try to consider the slide, but if you have no idea about the questions, then consider the answers on these slides, right? You have already learned all these short questions from your chapters, from your any book, so try to recall it, right? Now the chapter, now let's start. The chapter number is the 7. That is the short questions from the 7 chapters. This chapter is the thermochemistry, heat related topics are there. For example, according to smart syllabus, there is enthalpy in this chapter included, internal energy included, and work done included, and first law of thermodynamics is included. Some of the short questions which I am going to deliver, one of them is that differentiate between the internal energy and the enthalpy. So in this chapter we have studied in classroom study what is the internal energy and what is the enthalpy. Before the internal energy enthalpy explanation, I am going to give the idea of the system and surrounding. The system, anything which is under observation is called a system, and the boundary and around the system is there is a surroundings. So here first thing is that if you have any gas, solid, liquids in the system, in a beaker, that is called as the system, and outside the system, that is called as surrounding, right? So what is the internal energy? Question is that differentiate between the internal energy and the enthalpy. Internal energy is what? You know, there is 2 type of the energy. Is the total energy of all the possible kind of energy is called as the internal energy. There are 2 types of energy, you know, kinetic energy and the potential energy. What is the kinetic energy? Potential energy is due to the position, right? But in the chemistry, there is attraction between the molecules is considered as a potential energy of the system. And what are the kinetic energy? There are many types of the kinetic energy. Number 1 is the transitional kinetic energy. This is due to the movement when the molecule changes place from one side to other side. That is called as a transitional kinetic energy. Rotational, as the name indicates, when they are going to rotate and vibrate on the system. So total kinetic energy, which are further divided into the rotational, transitional, and the vibrational energy, and plus the potential energy, which is due to the forces of attraction between the atoms, is called as the potential energy. Total type of energy within the system and all the possible kind of energy of the system is called as the internal energy of the system, right? It is expressed in a joule. We are not able, we are always taking the change of energy, right? We are going to consider the change of it is shown by the capital E. Next thing is the next topic is the what is the enthalpy. Enthalpy in always question raises what is the difference between the heat and the enthalpy. Here enthalpy is another term in the thermochemistry chapter. It relates with the total heat content of the system. Now the total heat content of the system is how is it represented? It is represented with the H is equal to E plus PV. What is the E? Enthalpy indicate the total heat content of the system. It represents with the capital H, and it is equal to the total energy of the system plus pressure volume work. Right? So this is the product of pressure volume work, and the energy is called as the enthalpy, that is the heat content of the system. In this chapter, we have studied about the enthalpy topic. In this topic, we have considered a system under observation, and when the system, when you are going to give the heat in the form of the heat, what happened? The internal energy of the system is increases. The molecules are going to be increased their kinetic energy as well as in their potential energy. So total energy of the system is going to be increased. And if there is a work done by the system in the chemistry, work done is what? Pressure volume work. What does it mean? If it increase the, I have drawn a picture in the classroom study. When you have to, when the internal energy of the system increases and the pressure which are going to keep constant at 1 atmosphere pressure, and volume change from V1 to V2, and this change of the volume, and this change of the volume and the change of the pressure, pressure volume work, that is called as the change of the volume. Change of the volume is called as the pressure volume work. Pressure volume work done by the system, right? Some work is done by the system and some work is done on the system. If the system gives heat or any work, change the piston position, change the volume, then system does work on the surrounding. This is called as the work done by the system. If the work is done from the surrounding to the system, that is called the work done on the system. So enthalpy is what? If the heat content of the system, which are the heat of content of the system, is equal to total change of kinetic energy, total internal energy plus the pressure volume work either done by the system or done on the system. I have already. Now differentiate between the internal energy and the enthalpy change, and what has heat provided to the system increases, its internal energy from E1 to E2. The difference of these two energies is called as the change in energy, right? If the volume of the system is not allowed to change, then delta V is equal to 0. Then all the heat supplied to the system only increase the internal energy of the system. What is the internal energy? How do you discuss the internal energy of the system? If you have to go, if Q heat is provided to the system and there is no change in the volume, there is no pressure volume work, all the heat is continued to provide the system for change of the internal energy, right? This one is the differentiate in the change of internal. If the pressure of the system is kept constant, so Q heat is used to increase its enthalpy. What is the enthalpy? Product of internal energy plus pressure volume work, right? If there is it is the difference of the enthalpy of the system in the initial state and the final state. One thing which is left, which is very important to explain, this is the state function, right? Not dependent on the path, right? So this is called as the state function, and the enthalpy and the change of internal energy. If the pressure of there is two enthalpies we have discussed. One is the at the constant pressure and the constant volume, at the constant volume and the constant pressure. If there is Q heat is supplied and there is no change in the volume and there is no pressure volume work is done, all the heat supplied to the system increases just the total kinetic energy of the system. But if there is change of the for example, if pressure volume work, that is equal to change in the enthalpy of the system. What is the change? Initial stage is the E1 and the final stage is the change of internal energy, because at the any stage we didn't measure the exact internal energy of the system. Now next question is that what is the difference between the exothermic reaction and endothermic reaction? As the name indicates, I have already told you about the system under observation and the surrounding. If the heat is allowed from the system to the surrounding, that is called as the exothermic reaction. If heat is absorbed to proceed the reaction to convert the reactant into the product, then that is called as the from the surrounding, that is called as endothermic reaction. What does it mean? For example, exothermic reaction, heat is evolved from the system, and the temperature of the system rises. Temperature of the system rises. Enthalpy of product is less than the enthalpy of the reactant. That point is also very important. Sign of enthalpy change is always negative. They are normally spontaneous reaction. So what is the exothermic reaction? When the heat is evolved from the system to the surrounding. So the temperature of the system of course rises, and the enthalpy. When does the exothermic reaction occur? When the enthalpy of product, I have draw a graph between the enthalpy of the product and enthalpy of the reactant. In the exothermic reaction, enthalpy of the product, total heat content of the product is less than the enthalpy of the reactant, and sign shows the negative sign. Next is the endothermic reaction, when the heat is absorbed to proceed the reaction, otherwise it is not proceeded from the surrounding to the system, that is called as the endothermic reaction. Temperature of the system decreases, enthalpy of product is more than the enthalpy of reactant. Sign of enthalpy change is positive, and so many reactions are there, just like a photosynthesis is type of the endothermic reaction, and other so many reactions. Next chapter is some of the questions are there from the next chapter, that is called as the chemical equilibrium. What is the chemical equilibrium? When the rate of forward direction is equal to the rate of backward direction. For example, when the nitrogen reacts with the hydrogen to form the ammonia. So, when the rate of forward direction becomes equal to the rate of the backward direction, then this stage is called as the equilibrium stage. When this stage occurs, first of all, reactants are reacted continuously to form the product. After some time, product is converted into the reactant, and at the one time both the lines of the graphs, rate of forward and rate of the bar, becomes the parallel, which shows it's not a static, it's not a stopped, but it is continued, but the rate of the reaction and the forward and backward becomes the equal. Chemical equilibrium depends upon the there is 2 and 3 terms, equilibrium constants, equilibrium position. Equilibrium constant is a constant value, and the equilibrium position product of products to the reactants are changeable, and they are trying to change to compensate to keep the constant Kc constant, that is called as the Kc equilibrium constant. So spontaneous, non-spontaneous reactions, and the equilibrium, chemical equilibrium, Le Chatelier's principle, all these topics are according to the SMART syllabus. First question is there, reversible reactions. One thing is very important before starting this, reversible and the irreversible reaction. If the reaction proceeded in both the direction, reactant converted into the product and product converted into the reactant, then it is called as the reversible reaction. Irreversible reaction, when reaction goes in one direction, reactant are totally converted into the product, then they are called the irreversible reactions. So reversible reactions which proceeded in both the directions attain the position of equilibrium, which is dynamic in nature and not static. One thing is very important: reaction is not stopped. Either it attains the equilibrium, either the rate of forward direction and becomes equal to the rate of backward direction, but it's not stopped, it's not static, but it is called a dynamic in nature. How is it dynamic reaction? In a reversible reaction, when the rate of forward reaction becomes equal to the rate of backward reaction, then equilibrium is established. This is very important, and the parallel line is achieved. As you know the graph, there is a parallel line. First of all, forward direction steepened and falls, and next the rises the product side, but at the stage come when the parallel line is achieved and equilibrium is established. At this equilibrium, a reactant and product is still converting. It's not stopped, but it's dynamic equilibrium. It slows down due to the concentration, but they are slowed down. They are continuously converting, but there is not static. You cannot say the reaction is stopped. Reaction is dynamic, achieving the dynamic equilibrium. Why the reaction rate slow down when a reversible reaction approaches equilibrium? When it attains the equilibrium, what happened? Rate of reaction is, directly proportional to the concentration of the reactant according to the law of mass action. When reversible reaction approaches equilibrium, the concentration of the reactants is going to be decreased. Hence, the rate of the reaction slows down, but is not stopped. That is also very important question. The change of volume disturbs the equilibrium of position for some of the gaseous phase reactions, but does not equilibrium constant. Le Chatelier principle says if any change, either volume change, temperature change, pressure change, anything else, any condition change, equilibrium is trying to keep the equilibrium constant. Means Le Chatelier principle says Kc remains constant, equilibrium position ratio of the product to reactant, that is called as the equilibrium position, that is going to be changeable. Right? If you increase the volume at the equilibrium, reaction either converted into the forward direction or backward direction, but the Kc remains the constant. So we say position of the product to the reactant are going to be changed. Equilibrium position is changed, but is trying to keep the Kc constant by changing the equilibrium position. So change of volume, if you are changing the volume, and reactants converted into the products. If you increase the if you remove any reactant, some of the amount of the reactant, for example, N2 plus hydrogen is equal to ammonia. If you increase the concentration, for example, increase or decrease anything else, if you increase the concentration of hydrogen on the reactant side, what happens? Equilibrium will be disturbed. Now, how the equilibrium is maintained? More reactions are followed in the forward direction to compensate, to keep the Kc constant. If you remove one of the product, for example, ammonia is formed at the stage of equilibrium. I have given you example, nitrogen reacts with the hydrogen to form the ammonia. If equilibrium is established, ammonia is present in at the stage, you have to take out some ammonia for your uses. What happened? Reaction proceeds in the forward direction to make a more ammonia and to keep the Kc constant by changing the equilibrium position. So this is the way. This is the change of the concentration of any reactant or product. How does it keep Kc constant? The change of volume disturbs the equilibrium of position for some of the gaseous phase reactions, but does not equilibrium constant. One thing is very important. Change of volume is very important. If there is a reactant changes into the product, reaction in which a mole of the reactant and products are equal on both sides of the reaction, so equilibrium is not disturbed by change in the volume. One thing is very important. If there is a number of moles are same on both the sides of the reactant and the product, what happened? So it means there is no change in the volume. But if the reaction in which the number of moles of reactant and products are not equal, then you have to disturb it by the change in volume. The ratio of forward rate constant and reverse rate constant, Kc, remains unchanged, but the equilibrium position is going to be changed. In this chapter, some of the topics are there: reversible, irreversible, law of mass action is not included in the SMART syllabus, and equilibrium position, equilibrium constant, Lee-Chatelier procedure and synthesis. And one of the topic is pH, pUH. Now, pH is what is this? Negative logarithm of hydrogen ion concentration. pUH, negative logarithm of hydroxyl ion concentration. And buffer solutions. Buffer solution is which is keeping its pH constant by the little addition of the acid or the base. How the buffer is formed? You know, that is the combination of consists of weak acid and salt with a strong base, just like acetic acid and sodium acetate makes the acidic buffer, and basic buffer which is the consist of weak base and salt with a strong acid, ammonium hydroxide and ammonium chloride. I have written a equation which shows how it keeps its pH maintained, right? How it keeps its pH maintained. There is a keeping its pH maintained, so that is very important. It's a very important in the long question point of view, but there is a sometimes there is a what is the pH, what is the pOH, how the pH keeps constant, what is the Henderson, and the acidic buffer, basic buffer, how the buffer, what is the buffer and how it maintains. In my next lecture I will sort out some more question from the pH and the buffer topics, and next I will go to the next topic. Inshallah, I hope you are trying. Thank you so much.